Hello, PreCalculus. Welcome to Chapter 2. We are moving quite along. Chapter 2 is all about graphing functions, solving some functions. We do a little bit with power and radical functions. By that we just mean like x cubed, x squared, x to the 1/2, x to the 5/2, stuff like that. We're going to do monomial functions in section 2.1, and we're going to solve some square root functions, go through that again. And then in section 2.2, we start going into polynomials, and we'll dive deep into polynomials and dive deep into rational functions. But today's a little light still. We're going to start off with power functions, monomials. These guys here, the top two here, I can't get it to work. These top two here, what do they look like to you? Hopefully you're saying parabolas, and parabolas would be something that's like x squared. This is also the general shape of a graph of, say, x to the 4th, x to the 6th, x to the 8th. What do you notice about those guys? They're even degreed monomial functions. They're going to have a general parabola-ish shape. They're going to go through 0, 0. They're going to end up pi if my leading coefficient is greater than 0. If my leading coefficient is less than 0 or negative, they're going to open downward. So open upward, leading coefficient is positive. Open downward, my leading coefficient is negative. The two on the bottom here, what does that look like? X cubed. So x cubed, x to the 5th, x to the 7th. It's going to have that general end behavior, general shape to it. Now it would make it more flat in here, say, and look more like that. Just like these guys, the more you get to like x to the 10th and stuff, it'll really bottom out here. But they have the general end behavior shape. And again, if we're increasing here, that's when A is positive. When A is negative, we've got a decreasing function. So we're going to take that information. We're going to analyze some monomial functions. These are just basic monomial functions. We're going to graph and analyze them. It is not going to be a precise graph. We're just going to go off of what we do know. We're going to describe the domain, range, intercepts, end behavior, continuity, and where the function is increasing or decreasing. This should be a review of everything we did last chapter. And then I also added in, we're going to state whether it's even, odd, or neither. So x to the 4th with a positive leading coefficient is going to be a parabola shape in its nature. It's going to go through 0, 0. So this guy is going to have a domain of negative infinity to positive infinity, right? But the range is from what to what? What's your lowest y value? 0 up to positive infinity. It's x-intercept and y-intercept. We only have one of each. Those guys are 0, 0 for both of them, right? End behavior comes next. So the limit as x goes to negative infinity of f of x, where is it going to? It's going up to positive infinity. And the limit as x goes to positive infinity of f of x, well, as x goes to positive infinity, y's are also going to positive infinity. It is a polynomial function, which means I do not have any asymptotes. I don't have any domain restrictions. So it's going to be continuous on its entire domain. So continuous on all real numbers, negative infinity to positive infinity. Where are we increasing? This function is increasing. Where do the y's get bigger? The y's are getting bigger from 0 to infinity. Do we include 0 in that interval? No, we don't. And some people lost 6 points on the test because they chose the answer option that would say like 0 to infinity. When I'm at 0, can you tell me at this point here, is it increasing or decreasing? Neither. It's turning, right? It's the point where we go from increasing to decreasing, but the 0 doesn't belong to increasing and the 0 doesn't belong to decreasing. All right, where is this graph getting smaller? That's going to be from negative infinity to 0. Is this graph even, odd, or none of the above? This one is symmetrical about the y-axis, so it's an even function. All right. That's it for A. B, I have an odd degreed function. It's got a negative leading coefficient. So instead of looking like this, it's going to be decreasing. I guess I should put a coordinate axes there. All right, and goes through 0, 0. It may be a little bit fatter, it may be a little skinnier, but it's got that general shape. And from that, we can find everything they're looking for. So domain, this guy's going from negative infinity all the way to positive infinity. Do we have any restrictions on the range? Not this time, right? It's going down to negative infinity, up to positive infinity. All right, x-intercept. We only have one intercept. If it's a monomial, it's got to go through 0, 0. And that's also our y-intercept. Now when we start adding other terms like negative x to the 7th plus x to the 5th minus x cubed, it's going to do all sorts of fun things in there, and that's comes up in chapter 2. All right, end behavior. What's the limit as x goes to negative infinity of g of x? So as we go to negative infinity, our y's are going to positive infinity. The limit as x goes to positive infinity of g of x. As we go to positive infinity, we are going down to negative infinity with our y's. Again, it is a polynomial. We have no asymptotes, no holes, no domain restrictions. So we are continuous on all known numbers. Negative infinity to infinity. Where are we increasing? Nowhere. This graph is always decreasing. So increasing interval would be none, because we are decreasing negative infinity to positive infinity. All right, is this guy even, odd, or none of the above? Kind of hard to tell from my rough draft here of the graph, but it is an odd function. It's symmetrical about the origin, if you look at it exactly on Desmos and get a more precise graph. All right, C, go ahead and pause your video. See if you can figure this one out, and come back when you think you got it. All right, we've got another positive leading coefficient, and it's even, so it's going to look parabola in nature. Everything about this function is going to look exactly like this one here. So check your work, see if you got your domain, your range, x-intercept, everything looks exactly like that top one there. It's another positive leading coefficient, even degree, it will look exactly like example 1a. Coming up next, we're going to do some negative exponents.